have a few vocabulary words that we want to talk about. All right. Our first vocabulary word will be point. Our next vocabulary word will be line. Next vocabulary word is line segment. Next vocabulary word is ray. Intersecting lines. When we talk about a triangle can be classified in 6 different ways. We're going to talk about that a little bit tonight too. Scalene, isosceles, equilateral, acute, obtuse, and right. When we talk about lines, they can be parallel, they can be intersecting, or they can be perpendicular. We'll talk about that later on as well too. We have angle. Okay, there are 3 different types of angles. You have the acute angle, the obtuse angle, and the right angle. And we'll be talking about these and some other vocabulary words later on. Today, I'm going through my math library. I found this book called Twizzlers, Shapes and Patterns. Twizzlers, Shapes and Patterns. So just like last week I did with our Skittles book, I'm going to be reading this book as well today. And this is called Twizzlers, Shapes and Patterns. So I'm going to talk about some triangles, and I'm going to talk about some squares, and talk about some patterns later on. This is by Jerry Pallotta, illustrated by Rob Bloister. So it's just amazing what different people can do. So all I'm doing here tonight is I'm bringing this book to life. And this is something that can be either at the beginning of a unit, or it can be at the time we start our SOLs when we want to review. But here we go. Very good book as well, too. Twizzlers, Shapes and Patterns. Our school is under construction. An architect came off the job site and walked into our classroom. She uses designs buildings, but today she is teaching us how to draw shapes. Point. Line. The architect drew a dot and told us it was a point in space. We knew it was just a dot on the chalkboard. Then she drew away from the dot to make a line. And as you can see right here, this first thing right here, you're going to see it in just a few seconds. This purple or burgundy piece right there is a point. Then we have our Twizzlers that represents our line. So right here, this is my point here. I love it. This here is representing our line for tonight. Point, line. Okay, and we'll look at that in just a few moments. My point and my line. I'm going back to my book. It says, during the lesson, our teacher gave the class a snack. It was Twizzlers Twist. Yeah! Right away, I decided to use my strawberry twist as a line. Okay, and so that's what this piece is for tonight. This is going to be a line. So this represents our line for tonight. Okay, and this is our point. Okay, because who got the point? I got the point. Now, the next piece that I want to talk about is this thing called the angle. Okay, the architect drew another straight line. She showed us how to make an angle. Then she drew some more, and we learned about wide angles and skinny angles. Okay? Now, when we talk about wide angles and skinny angles, what we're really doing is we're talking about acute angles, obtuse angles, and right angles. Now, here's the issue that's going to take place. Once again, I have to have my point. Okay, I have to have my line. Okay, now the thing is, I'm going to take away my line for right now. I want to take away my line segment. We'll talk about line segment in just a few moments. That's what this orange represents right here. It represents the line segment. But what I do want to talk about is another piece called the ray. Okay, when we talk about our ray, okay, when we talk about our ray, it has a dot that serves as an endpoint. And it has an arrow. Why? Because that arrow goes on and on and on in only one direction. Just in case you may have forgotten, or maybe you didn't even know, that when you put 2 raised together with a common endpoint, guess what? We call it an angle. We call it an angle. Okay? And right now, that is an angle. And to give this angle a particular name, we're going to call this an acute angle. We're going to call this an acute angle. Okay? And it doesn't matter which way that you turn it, it's still going to be considered a what? An angle. Okay? And I'm just going to put these other pieces that I broke off to show the arrow. Why? Because they keep going on and on and on in both directions. So right now, this is our Twizzlers as a representation of what? Of an angle. And particularly right now, if I put this one on top of this one, this is technically an acute angle. Just in case you may have forgotten, when we're talking about an acute angle, guess what, folks? Acute angles start out at 1. It goes from 1 degree because we measure our angles in degrees. So you go from 1 degree to 89 degrees. Okay? That is what an acute angle is. It goes from 1 degree all the way to 89 degrees. Why not 0? If it was 0, that would be nothing. Okay? If you go one more to 90, that means it's going to be a right angle. So that's why your degrees is going to be from 1 to 89. Now, let me see, can I do this real quick? So if I got my arrow, that's still acute. Everything is still acute right here. Everything is still acute, no matter how wide you get here. Believe it or not, that's still acute, okay? Because it's not going to be right until you make a square corner. So all this is acute. Once again, when we talk about acute, it's going to go from 1 to 89. Now, what I like about this acute angle is, guess what? It looks like the greater than and less than signs. It looks like the greater than and less than signs. It also looks like the letter V. All of those symbols like that look just like the acute angle. So that's the first thing we want to talk about in this group right here. And the book here calls it a skinny angle. All right. Now, on the other hand, if I have my angle and I make it wide like so, that is called an, hold on one second, an obtuse angle. When you go like that, that's going to be an obtuse angle. What do you mean by an obtuse angle, Mr. Jones? When I talk about an obtuse angle, that is going to be 91 degrees all the way to 179 degrees. As stated before, when we talk about angles, angles are measured in these things called degrees. Okay? Let me see, can I set this up real quick? All right, right now that's a right angle. So if I go inside, it's going to be acute. So I do a right angle and I go backwards like so. And that's where we're going in this direction here. All of this is considered to be obtuse. And I said obtuse. Okay? And watch this. I can even go flat. If I go flat with it, that's going to be 180 degrees. Okay? So if we just go up just a smidgen, that's still considered to be an obtuse. Okay? So we've talked about acute. Those are the small angles from 1 degree to 89 degrees. We talk about the obtuse from 91 to 179 degrees. Which one is left over? That would be the right angle. That is 90 degrees exact. That is 90 degrees exact. Okay? So when we talk about that, that means it's going to be straight up and down. Okay? And in most cases, it looks like the letter L. Okay? And what we're able to do, we're able to make a square corner that way. Sometimes they look like that. Sometimes they look like that. Sometimes they can go that way. Sometimes they can go in that direction, okay? But as long as it's straight up and down, like the letter L, it's like a backwards L, it's considered a right angle. It's considered a right angle, okay? And I got a little song that I do that goes along with that. And if you want to help me out real quick, you can join me. I put my hand up like this, and I go like this, and I go right angle, right angle, right angle, right angle. A cute little angle, a cute little angle. Obtuse angle, obtuse angle. All right, you want to sing with me? Sing with me. Right angle, right angle, right angle, right angle. A cute little angle, a cute little angle. Obtuse angle, obtuse angle. Right? I can flip it. Right? Acute, obtuse. Angle, acute angle, obtuse angle, right angle. Right angle is exactly 90 degrees. Obtuse angle will be from 91 degrees to 179 degrees. And an acute angle is 1 degree all the way to 89 degrees. All right, let's continue our story. The first shape the architect showed us was a triangle. It has 3 sides and 3 angles. I made a triangle with 3 strawberry Twizzlers. It was really fun. I love to learn. Outside at recess, we pretended we were architects and construction workers. We colored on the playground with sidewalk chalk, and we drew triangles. So if you give me just a few moments here, I would like to show you some different triangles. What I have here is I have 3 different size Twizzlers here. Okay? I have red, which is strawberry. I have this purplish burgundy color, which is the mystery flavor. And believe it or not, I have a, what is this one here? This is a orange creamsicle flavor. I was like, what? So you'd be surprised what they're doing with our candies nowadays. Now, what's going to happen right now is I'm going to make what we call an equilateral triangle. I'm going to make an equilateral triangle. When we talk about an equilateral triangle, that means that all sides are the same. And if you can look right here, the Twizzlers that I have, the orange, the purple, and the red are all different sizes. So I'm going to make different size triangles here. And we're going to call these equilaterals. All right. This is my red equilateral triangle there. I'm going to make an equilateral orange. And when it's equilateral, all we mean is all sides are the same. All sides are the same. All right, so if you can see right here, these are my Twizzler triangles. I have red, orange, and purple. The cool part is, guess what? These are all considered to be equilateral because the reds are all the same size. The orange are all the same size, and of course the purple are all the same size. So the first one we want to look at is the equilateral triangle. Now, when we talk about equilateral, that means we're talking about the length of the sides. We're talking about the length of the sides. When all sides are the same. when all sides are the same. That's called equilateral. Now, what I'm going to do right now is I'm going to take one from each of these triangles here. Why am I doing that? Because I want to talk about when it has only two sides that are the same. That's called isosceles. That's called isosceles. When you have two sides that are the same. So what does that mean right here? I want to take this one here and close this out right here. This is an isosceles triangle. You have two sides that are the same here. All right, I have my orange here, and I put my purple here. This is also a isosceles triangle. Why? Because you have two sides that are the same and one that is not. And I got to stretch him out a little bit, but that's okay. This is still considered another what? Isosceles triangle. Why? Because when we talk about isosceles triangles, that means that two sides are the same. Only two sides are the same. Okay, so we got equilateral where all sides are the same. Equilateral where all sides are the same. Isosceles where two sides are the same. Okay, so now there's a funny word. Okay, scaling. Okay, we call it scaling. When we say scaling, I say scaling because I make like a funny, scary word. Because guess what? In a scaling, no sides are going to be the same. Okay? So let me see. Can I switch some things around real quick? So each of these triangles here is considered to be a scaling. Why is it considered to be a scaling? Because guess what? No sides are the same. Okay? Vocabulary check. Right now, I'm talking about based upon their sides. Based upon their sides. I have a scaling. We talk about isosceles, two sides the same. Equilateral, all sides are the same. Okay? Now, we just finished talking about angles. We talked about the right angle, the obtuse angle, and the right angle. So guess what? We can do the same with our different angles. Okay? So we're going to go here first. And technically, if you look at all of these are technically acute angles. Why are they acute angles? Because guess what? Each of these triangles has acute triangles in them. They have acute triangles. All angles are acute. All angles are acute. Okay? Now, I'm going to see, can I try this real quick? Got to put an extra piece in here for that. But what's happening here is this. This is what we call a right triangle. This is called a right triangle. Because what I'm doing with my red right now, I'm making a letter L on my side. Maybe it's an upside L for you. Okay, that's the L right there. And then you put this piece right here. And as long as it has at least one right angle, if it has at least one right angle, then guess what? It's considered a right triangle. That's all you have to do. As long as it has at least one right angle, it's considered a right angle. Okay? Considered to be a right angle. Okay? And you have a right angle in it, it's called a right triangle. It's called a right triangle. All right? So this is our example here. Okay? I will see, can I switch this over? See, can I try something else real quick? And yep, we can see that. As long as it has at least one right angle is considered right angle. All right, so we've talked about the acute triangle, check. Talked about the right triangle. Now the other one is going to be the obtuse. It's going to be the obtuse. All right, so that means it's more than 90 degrees. And that's the one I call it like a stretched out triangle. And there you go. 1, 2, 3. Because remember, triangle has 3 sides. That's the key thing. A triangle has 3 sides. So we've talked about the acute angle, the obtuse, and talked about the right. Now, what you need to know when you talk about our triangles, they are classified into 6 categories. We talked about the scalene tonight, which means it has no sides are the same. We talked about isosceles. They have 2 sides that are the same. We talked about equilateral. All sides are the same. On the next one we have is acute. When we talk about acute, it has at least one acute angle. But in most cases, it has all acute angles. To be obtuse, it has to have at least one obtuse angle. To be right, it has to have at least one right angle. All right. Let's go back to our story and see what's next. Just finished talking about triangles. The architect took out some fancy graph paper to help us draw a right angle. The corner of this book is a right angle. And that is correct. Now, we want to talk about some other lines. I told you before, this represents our line. Now, one set of lines that we want to talk about are going to be parallel. Okay? Another type of lines that we want to talk about, I feel like we're talking about addition and subtraction and multiplication. That's going to be perpendicular lines. Let's see, can I do this right here? Yep, there you go. Those are called intersecting lines. Parallel, parallel, intersecting, okay? Lines that are the same distance from each other and do not touch are called parallel lines. Lines that do not touch, they're called parallel lines. So what we have here is a set of parallel lines, okay? Here, it looks like the letter T or a plus sign right here. Once again, just like our right angle, it has 4 right angles when they meet. Okay, so we call these perpendicular, perpendicular. Now these that look like an X or a multiplication sign, we call these intersecting lines. Okay, so I have a song that goes along with this right here, and it goes like this. You can put them together, or you can grab your Twizzlers like this. Hope I can do that right. Touch it, bring it, touch it, bring it, parallel, parallel, intersecting, parallel, parallel, intersecting. Okay, so what I just did with that one right there, I like doing it with my hand motions to get my exercise in. I go like this, touch it, bring it, touch it, bring it, parallel, parallel, intersecting, parallel, parallel, intersecting. All right, so can you try it with me? Touch it, bring it, touch it, bring it, parallel, parallel, intersecting, parallel, parallel, intersecting. Notice I'm making my hands an X, okay? I can go with big arms. Touch it, bring it, touch it, bring it, okay? Touch it, bring it, touch it, bring it, parallel, parallel, intersecting, parallel, parallel, intersecting. Okay, so now I'm going to say read. remix. Okay, and this time I'm going to bring one across here and bring this up here like that. And now I'm making a plus sign, and I'm saying, not an X, a plus. Perpendicular, 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 perpendicular. Okay, I have my X, and I turn my X, and then I have plus sign. X, intersecting, perpendicular. Hear that plus sign? Perpendicular. Okay? And that's what we're talking about here. We got our parallel lines. They never touch. Okay? Lines that stay side by side, like those on the road. Like I was driving here from Petersburg earlier today. And guess what? On the road, you got these yellow lines that you're not supposed to cross over. They never touch. They keep going on and on and on and on. On the other hand, you have what we call intersecting lines. When we talk about intersecting lines, they cross. They cross eventually at one point or another. But when they cross, they just intersect. They make an X. On the other hand, you have them that do what? They make a plus sign. Those are at our intersection. So if you got a four-way stop that looks like a plus sign, that looks like this on your roads, those are now called perpendicular lines. Those are now called perpendicular lines. Questions or concerns with that? All right, I'm going to need your help real quick while I make a quick adjustment. I need your help while I make a quick adjustment. What I need for you to do at this time is in the chat, okay, name some four-sided shapes. Name some four-sided shapes for me. Take the next minute and do that for me. Name some four-sided shapes and go. All right. Thank you very much. What I've placed on my table here is this first one here is a representation of a square. Why is this considered classified as a square? Because number one, it has all right angles. It has four right angles, and it has all four sides that are the same. It has all four sides that are the same. So this is why this is considered a what? This is considered a square. Okay, because it has all red sides, they are all the same. All right, now this is another four-sided figure called a rhombus. This shape right here is called a rhombus. Okay, what was happening here is no right angles in this one, so it's not a square. There are no right angles in here. There are no right angles in here. Okay, but the cool part is, guess what? All sides are congruent. All sides are congruent. All sides are congruent. What I have here is a parallelogram. This shape is a representation or classified as a parallelogram. Why is this a parallelogram? Because it has opposite sides are congruent. Okay, you got the dark sides with this color right here is purple. These two sides right here are purple. These sides are red because opposite sides are congruent. And this one may look like a square, but guess what? It's actually a rectangle, okay? Why? Because all sides are not the same. All sides are not the same in this case right here. All sides are not the same. All sides are not the same, so this is considered a rectangle, okay? But guess what? Just like the square, they both have right angles. They have 4 right angles. Now, the cool part about these 4 that I'm showing you right here, guess what? All of them are considered to be quadrilaterals. Anytime that you talk about a quadrilateral, that means that it has 4 sides. Just like when we talk about the triangle, it has 3 sides. Okay, so this is what we got right here. This is our square. All sides are the same. And it has 4 right angles. Right here, I have a rhombus. Why is it a rhombus? Because there are no right angles, okay? But opposite sides are congruent. And in this case, in a rhombus, all sides are the same. Square, rhombus, rectangle. Why is this a rectangle? Because guess what? The opposite sides are congruent, okay? All sides are not the same. All sides are not the same. That's the difference between the rectangle here and the square. And a square, all sides are the same. Coming back here to our parallelogram. Parallelogram is just like our rhombus, but the difference is opposite sides are still congruent in our parallelogram, but the key thing is guess what? All sides are not necessarily the same. So that's the big difference right there. All right. So all of these are quadrilaterals. Now, I want to see, can I make a special quadrilateral that somebody just put in our chat and says, what about the trapezoid? Yes. The trapezoid is a special case quadrilateral. Okay. Now, let's see, got you. Now, the quadrilateral, we'll put 2 of these Twizzlers together. Still doing what we need to do. This is still considered a 4-sided figure right here. Now, in a trapezoid, you have, boom, only one set of parallel lines, okay? All right? Now, right now, if you look at this one, this is the funny shaped one right here. Okay? It looks like a trash can. I like it. I compare it to like a little trash can or a lamp top. And with this right here, these 2 sides are the same. Okay, these 2 sides are the same here, but the problem is they're not, all sides are not the same, because usually the bottom or the top is longer than the bottom, or vice versa, to make a trapezoid. And that's why, because it's longer at the bottom, that's why it has these on the side right here. Okay, so that is our trapezoid. All right, see what our book says. It says the square. Learning about parallel lines and right angles is important. Here's a square. Okay, we talked about a square a few minutes ago. All 4 sides are the same length. All 4 angles are right angles. Once again, when I pull out my Twizzlers here, all sides are the same. All sides are the same. And it says, here's a square. Here's a square. A square is a 4-sided shape. Check. All 4 sides are the same length. Check. All 4 angles are right angles. That is a square. Out on the playground, we tried to trick our teacher. One of the squares that we drew was not really a square. Can you figure out which one is different? Yep, they actually drew a trapezoid up there. They drew a trapezoid on this page right here. Another shape they talk about is this thing called the oval. This is not a circle. It is an oval. Ovals are egg-shaped. You could say that an oval looks like a circle that has been stretched or squished. Yeah. Race car drivers drive on oval-shaped tracks. The jogging tracks around football fields are oval-shaped. Can you think of any other things that are oval? Rectangles are everywhere. The architect told us to look at doors and windows. A rectangle has 4 straight lines and 4 right angles, just like a square. But only 2 lines opposite each other are the same length. But only 2 lines opposite of each other are the same length. Think about this. A square is a rectangle. But a rectangle is not always a square. I repeat. Think about this. A square is a rectangle, but a rectangle is not always a square. Our class could not decide which type is their favorite. Short rectangle, fat rectangle. But guess what? Rectangles or really long, skinny rectangles. You have to decide. Okay? Now, I'm going to attempt some other shapes. Because in our book right here, they talked about 3-sided shapes, 4-sided shapes. Okay? Now I want to attempt to make what we call a 5-sided shape. Okay? If you know what a 5-sided shape is, put that in the chat for me real quick. If you know what a 5-sided shape is. One, two, three, four, five. 1, 2, 3, 4, 5. A 5-sided shape is called a pentagon. A 5-sided shape is called a pentagon. 1, 2, 3, 4, 5. That is a pentagon. A shape with 5 sides is called a pentagon. This pentagon has 5 equal sides and 5 equal angles. 1, 2, 3, 4, 5. Here are my angles. 1, 2, 3, 4, 5. That's a pentagon. All right, I'm going to try this one right here. We've talked about a 3-sided triangle, 4-sided quadrilateral, 5-sided pentagon. Now I'm going to try to make a 6-sided figure. Do you know what a 6-sided figure is? What is the fancy name for a 6-sided figure? What is that fancy name for a 6-sided figure? One, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. How do you spell 6? S-I-X. And guess what? Its name has an X in it too. Count the sides of this shape. 1, 2, 3, 4, 5, 6. Now count the angles. 1, 2, 3, 4, 5, 6. This polygon is called a hexagon. Everybody say hexagon. H-E-X-A-G-O-N. Hexagon is a 6-sided shape. A hexagon is a 6-sided shape. All right. Now, we've talked about a 5, a 6, a 7 is called a heptagon. A 7-sided shape is called a heptagon. This architect lets you work on her laptop computer. We all drew a heptagon just like the one I saw on the computer screen. A heptagon has 7 sides. A heptagon has 7 sides. I'm going to attempt to make the heptagon, and we're going to see what we're able to do. 1, 2, 3, 4, 5, 6, 7. All right, this is a heptagon. The 6-sided figure was a hexagon with an X, but a heptagon has 7. Let's see, can we do this? 1, 2, 3, 4, 5, 6, 7. All right, it has 7 what? 7 angles, and it has 7 sides. Those are my sides. 1, 2, 3, 4, 5, 6, 7. How many angles? 1, 2, 3, 4, 5, 6, 7. So this is our heptagon with Twizzlers. And I have not eaten my Twizzlers yet, so don't eat yours just yet either. All right, here we go. We did 7. Octagon. An octopus has 8 legs. And an octagon has 8 sides. And an octagon has 8 sides. As your teacher and the architect talked, I realized we could draw hundreds and hundreds of different shapes. But right now I'm going to see, can I make this octagon, make this octagon with the Twizzlers. So give me a moment. One, 2, 3, 4, 5, 6, 7, 8. Woo! Just replacing a few parts to see it just a little bit better. One, 2, 3, 4, 5, 6, 7, 8. Octagon. Woo! Making me nervous, folks. Making me nervous. After an octagon, there's a 9-sided shape called the nonagon. A nonagon has 9 sides. Our whole class tried to think of a nonagon in our town or near our school. We couldn't think of any. Maybe for homework, our parents can help us find one. Okay? So while I attempt to make this nonagon, see if you are able to think of where have you seen a 9-sided figure at? Where have you seen a 9-sided figure at? Oh, wow. All right. I'm going to try to replace some pieces in here to see what I can do, but this is a nonagon. A nonagon in Twizzlers. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow. All right, so we got a 9-sided figure. A 9-sided figure is called a nonagon. Woo! I'm nervous, folks. I'm nervous because a nonagon is 9 sides. After the nonagon comes this thing called the decagon. Woo! That's 10 sides. A decade is 10 years long. A decagon has 10 sides and 10 angles. We alternate the flavors, strawberry, licorice, strawberry, licorice, strawberry, licorice, to make this shape. Our teacher told us we were making a pattern. Okay? I will see, can I replace with one of these in just a second. But right now I'm going to see, can I focus on making this 10-sided figure. So give me just a moment. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woo! That is a 10-sided figure using licorice. That is our 10-sided figure using our licorice. Okay? That is our 10-sided. This is called a decagon. All right, let me see. Can I make sure I can remember everything? 3-sided figure, triangle. 4-sided figure, quadrilateral. 5-sided figure, pentagon. 6-sided figure, hexagon. 7-sided figure, heptagon. Hep, gotta push that P, heptagon. 8 is that dude in the ocean, the octopus. So that's 8 sides is your octagon. 9 sides will be your nonagon. And 10 would be your decagon. Woo! And I'm going to stop right there. Okay? Now, the last thing we want to talk about is this thing called patterns. Okay? So help me out real quick and put in the chat, what is a pattern? Tell me what a pattern is in your own words. What is a pattern? In your own words, what is a pattern? All right. Here is another pattern. One orange candy, 2 red candies. 1 orange candy, 2 red candies. 1 orange candy, 2 red candies. All but one of the patterns on this page goes 1, 2, 1, 2. Can you find the different pattern on this page? You got to look at the pattern on this page and look at this. Okay? Now, some people call this 1, 2, 1, 2, 1, 2, or they use the alphabet and says A, B, B, A, B, B, A, B, B. But it's still a pattern. This is actually called a repeating pattern. Everybody say repeating pattern. Love it. Thank you very much for doing that. All right. Let's see, can we try another pattern from the book? And how about this? Let's switch this around. It's still a pattern. 2 reds, 2 purples, 2 reds, 2 purples. And if you want to, the book says you can call this a 2-2 pattern. 2, 2, 2, and 2. Okay? That is what we're working on right here. I like this pattern the best. Let's try this. 3 oranges. 1 purple. 3 oranges. 1, 2, 3. 1 purple. 1, 2, 3 oranges. 1 purple. So guess what will come next? What do you think is going to come next? Put in the chat what you think is going to come next. You guessed it. 3 oranges. Okay? And when we do that, that is how we continue the pattern. That's how you continue the pattern. Okay? Let me finish this up. Here's one more pattern. Two oranges, red, 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 purple. What's going to be next? Orange, three reds, and a purple. Orange, red, purple. Orange, red, purple. But how many do you have here? 2, 3, 1. 2, 3, 1. All of these are still considered to be what? Patterns. And that is the conclusion of our book for tonight. Okay? Haha, funny. The architect says we did a great job learning our shapes. And you did a very good job of learning the shapes with me tonight. My teacher says I'm a star. So guess what? You are a star as well too. I thought about it. I'm really 5 triangles with the pentagon in the middle. So that is the story we read tonight. Once again, it's called Twizzlers, Shapes, and Patterns. Twizzlers, Shapes, and Patterns by Jerry Pallotta. Illustrated by Rob Bloister. I want to thank each of